Welcome everyone. Thank you for joining. We will be talking a little bit. It will be more like a discussion, kind of like slash presentation, slash, just sharing what we have been learning about working with these two projects, Dapr and Testcontainers. Thank you for joining. I will share my screen. We have some slides, but we rather not use the slides and just have more kind of like a conversation and see where it takes us. And also we will be showing some live demos, I think, and just showing some technology in general. So let's do that. So Oleg, can you see my screen?
Yes, absolutely.
Good stuff. So that's kind of what I just said. Dapr and Testcontainers. Those are the main projects that we're going to be covering today. The agenda, it's going to go like that. We thought about talking a little bit about distributed application challenges and shared concerns. What is Dapr? What is this project? How Dapr can help you kind of like building distributed applications, and then how Testcontainers can help into that story as well. Oleg, do you want to introduce yourself?
Yes, thank you. Hi, everyone. My name is Oleg Shalaev, and I work at a company called AtomicJar. I'm doing developer relations for AtomicJar, and one of my main areas of interests are tests and the projects called Testcontainers. Testcontainers are open source libraries, and the whole startup AtomicJar was created by the maintainers of Testcontainers. We are trying to make developers more productive by giving you tools to build ephemeral infrastructures locally very, very easily. We're going to show it in action, and yeah, I hope you like it.
Yeah, that's pretty good. And correct me if I'm wrong, was Testcontainers created first mostly on the Java community, or that's kind of like a wrong statement?
Yes. So the project currently has multiple implementations in different languages, including the most popular ones like on the JVM, .NET, Golang, Node.js. The most recent edition was Ruby. But nice. The original inspiration came from the Java ecosystem, and now the different versions and different implementations are they are mostly up to the same level of functionality wise, but there could be some subtle differences between them because they try to be idiomatic for the language. And well, today we're going to look at the Java, how like Java library looks like in Java API, but the other languages are pretty similar. So if your main language of choice is, for example, Golang, you will find the same or very similar concepts and approaches, but will packaged as a normal Golang library.
Yeah, and I think that's good to mention to the audience, right? Like no matter what your programming language or tech stack is, like Testcontainers and the functionalities that we are going to be showing here today kind of like applies like to a polyglot world, I would say. Right?
Yeah, absolutely.
Good stuff. My name is Mauricio Salatino. I work for a company that's called Diagrid. I'm at Salaboy in Twitter, and I'm writing kind of like that blog, salaboy.com, for like at least 15 years now. And I've been involved with a bunch of open source projects in the last 4 or 5 years that are all kind of like related with the cloud native space and mostly on the Kubernetes side of things. But my background was like as a Java developer. Now I'm writing a lot of Go code as well. So when I, get in touch with the folks from Testcontainers, I realized that, okay, there might be a lot of synergy here because what's happening, at least in the cloud native space, is that we are getting closer and closer to developers. We want to bridge that gap of running containers in remote clusters and kind of what's the inner cycle for developers and building their own applications. So I think that we will be presenting about this specific topic today, but if you're interested in all these other open source projects and the cloud native space, I'm also writing a book that's called Platform Engineering on Kubernetes, where I kind of like touch on both kind of like the developer side, plus on the infrastructure and, how do you glue all these tools together to build platforms on top of Kubernetes. That's the QR code. I will be sharing the link later on Twitter as well, if you're interested. And there is like a 40% discount going on now on the Manning side. Again, if you're interested in that topic, feel free to check that out. So, Oleg, should we start by discussing a little bit about like what applications usually do? Because I think that we need to bring some context to this conversation. Does that sound like a good idea?
Absolutely. Different ecosystems, different languages, different projects. Let's set some sort of ground rules for what are we talking about.
Exactly. Yeah. Have you ever seen, let me start with this question. Have you ever seen a company that just have a single application?
Uh,
That's strange, I would say. I don't know, kind of like your experience.
well, no. We are talking about the reasonable industrial companies who are trying to solve some business problems. So most probably they have more than a single application. And nowadays it's very, very common that when we talk about applications, we actually talk about like a system of services. They can be microservices, or they could be, some of them could be large services, or like the sort of legacy monoliths that were carried over the years. But usually we're talking about a number of applications working together. And that is what developers are dealing with on the day-to-day basis. This is what the deployment looks like. So usually it's more than a single application for sure.
Right. And if we talk about testing, right, like if you have multiple applications, then you will need to have some sort of way of simulating the other application or even bootstrapping the other application. So whatever you are building that needs to interact with this other thing, it's available for running your tests and for guaranteeing that when you run these two things together, they will work. Right?
Yes, exactly. For whatever your system is, to have to have a productive software development cycle, you need, well, sort of the environment parity between your production and your CI systems to verify that whatever code you're pushing actually behaves the way you want. But you also need some sort of environment parity between your development and CI, because whatever you do, the source of all the issues or fixes originates in development. Like that is your development machine. So that means that you need to be able to reproduce your environment and your like issues that your CI uncovers or you're uncovering production. You need to reproduce them locally, because otherwise you're going to be shooting like in the dark, trying to fix issues without like fixing something without reproducing it. It's almost always not the smartest idea. So yeah, you need some way to run like a part of the system or like a larger part of the system on locally.
Yeah, definitely, 100%. And when you think about like these, like smaller applications or like these applications that are interacting between each other, I usually tend to think that large percent of these applications will be like executing or implementing different behaviors. And one of the first behaviors that comes to mind, at least to me, is like writing and reading data, right? Like when I think about applications, most applications, they will need to persist some kind of data and then go back and read that data to make sure that, for example, if the application crashes, the data is still secure and it's safe and the application can restart and everything kind of keeps working. Would you agree that around like, let's say 80% of applications are like in charge of reading and writing data, maybe to a database, a file system, maybe a bucket, maybe a cloud service?
Well, all applications just manipulate data, like on a
That's it.
fundamental level, right? But
Yeah.
yeah, most of the applications will be, I think in my experience at least, most of the applications are, they get data from somewhere. That could be like a sort of data store or an event bus or a message queue, and they transform the data in some way. And it could be, or it could be like user requests as well, right? And data can come from the
Exactly.
user, but they transform that data in some ways, and then they write data back into one or more systems, including maybe sending responses to the user, who might be like an actual human being, like clicking on their phone or something, or like clicking in the browser, or it could be other systems that they just consume your API.
Exactly. When you think about storage, what's the first thing that you think about? Like if you need to build an application that needs to store data that needs to be stored for, let's say, for a period of time, more than a month, what's the first thing that you would do? Kind of like, what's the first things that you will use?
Before I joined AtomicJar, I worked at Oracle on the project called GraalVM.
There you go.
So
I think that
I would
we have
say
an answer.
I would say of course S3. That's the
that's
the data store
preferred
that
place.
powers the internet. No, I'm kidding. Of course, like most normally, it's the classic example is the database, right?
Yeah, like PostgreSQL or MySQL or Oracle or something, right?
Yeah, or NoSQL things, or like a Redis for key value store, or like graph databases lately are being more and more important, or at least popping up in my bubble.
Perfect.
where there are like, but they're naturally, there's just different ways to query the data, different ways to store the data that allow you either some operational benefits or like sort of development time, like utilities. Like, so
Makes sense. Yeah, that makes a lot of sense. I think that the next thing that I think about when I think about these applications in a generic sense, I would say that I've seen a lot applications emitting events or consuming events using some kind of like asynchronous message bus or like message broker or even a cloud service that allows to move information between one application and the other, but not in a synchronous way, not by sending a request and waiting for a response, but more like you can place a message somewhere and then a consumer can go and pick it up from there. Have you seen this also like in a lot of applications?
yes, of course, because that's how the real world operates, right? In the real world, when you have a like a transaction at the grocery store or I don't know a bodega or something, there is no like ACID guarantees, right? Like
Exactly.
you get your produce and you give some money and then like the money doesn't check out, like you give too much or they need to give you change back or I don't know, like something
Yeah.
happens and then the world runs on the asynchronous events. We react to things and they of course we build the systems to do the same way, right?
Yeah, exactly.
Like there are like not always they're needed, but like very often this is just a sensible architecture. So it's
Yeah,
very, very common use
100%.
case.
Yeah, that's 100%. And then the last one, it's just, of course, if you have multiple applications and services, they will talk to each other, right? You will need to have some way or mechanism to make sure that application A can reach application B and they can exchange information. And that's how you build more and more complex systems, right?
Yes, and this communication can be through like a direct invocation, like like a REST API or any other protocol like gRPC or whatever, or it could be through message brokers as well. That could very
Yeah,
easily be your protocol for the applications. But yeah, that's the whole point, right? Like that's
yeah.
like when you break a system into multiple like services, you essentially want them to sometimes communicate. Hopefully the
That's
same language, hopefully the
exactly.
same protocol.
Hopefully the same. Yeah, they talk the same language. And this is kind of where it becomes really important, the fact that you should have the right tools if you're building polyglot applications to communicate applications that are being written in different languages, right? Like they should still be able to talk to each other. They should be still be able to store and read data in a similar way, without like being so into like your tech stack that it's completely incompatible with other application that somebody else might be writing. And I think that with that, like with these questions, basically what we wanted to try and bring is some context around like the kind of applications that we are talking about, like distributed applications. They store and read data, they exchange messages, they talk to each other. And I've seen this so many times in my last 10 years, like of working professionally on building applications that it's just a common pattern. And I think that that's where that's the context that we need in order to start talking about like test containers, how test containers can help into this context, and how Dapr can help as well by bringing some kind of like standardization around how do we do these things. And again, going back to what usually applications need, they need infrastructure. All these things that you are not going to build in-house, but you are going to consume as a user. So you can store data, for example, in PostgreSQL or in MySQL, or maybe send messages using Kafka or RabbitMQ, or Amazon SQS, like in a cloud provider, or in Google PubSub as well. You can consume these services, and it's up to your organization to define which services do you want to consume. And if you have access to the cloud, you will probably go for that, so you don't actually need to manage these components. But no matter which one of these you choose, you are still building the same behaviors. You are still storing data, you are exchanging messages, and you are in exchanging data across applications. The relationship between the application and the infrastructure, it's a complicated relation, right? I don't know if you're building Java applications or Go applications, it doesn't really matter. You usually need to have some kind of dependency inside your application to be able to interact, right? So if you have a Redis instance, you need the Redis client inside your application. In this case, I have two applications, one reading and writing data, and both they need the same client to be able to connect to that database, in this case to Redis. If you need to upgrade both like the application or Redis, you are kind of like you have like a tight relationship there of if the the Redis version needs to be upgraded to version 4, you need to make sure that your clients and all your applications that are connecting to that database will be upgraded as well, right? And this is like, this relationship can create complications between the team that is running the Redis instance and the teams that is like in charge of releasing new versions of the application. So you need to take that into account. Kafka, same problem. Any other database, any message broker will need to have some kind of client in order to consume. So basically, the first thing that we notice is that relationship between applications and adding dependencies to applications that will connect to infrastructure, it's something that we can try to improve, right? Because again, we know what we are doing with these pieces of infrastructure, so we can just start bringing some common patterns and some common solutions for start solving these. These problems becomes a little bit more complicated when you have frameworks and when you are going kind of like into a more polyglot world. Again, in that situation where different services are being written in different languages, and you want to guarantee that they are both reading data and writing data in the same way. You have Go and Java applications. You might have Spring Boot in one side, and then just writing Go applications without any framework or anything, just consuming the client. And it's pretty difficult to guarantee that these two applications will behave the same, right? And that's something that we will try to avoid if we are writing and reading data, that those operations should be managed in the same way, and the application should behave in pretty much the same way. In scenarios like this, Oleg, test containers will help you to basically get started with the infrastructure, right? Like you will be able to start your applications and then connect with the provider, like in this case, Redis instance that is being managed by test containers. Is that right?
Yes. So test containers gives you the API to run applications in containers, right? That's the name. So what we sort of call it, like the tagline for that would be like run your unit tests with real dependencies, where dependencies are exactly those infrastructure services that you depend on, either databases or message brokers or anything that runs in containers. And test containers libraries give you the API to manage those. So you would have very easy time creating environments for your tests or your local setup with test containers.
At least I think that's trying to solve a challenge that at least I've seen in the Java communities, where we had some in-memory alternatives for running kind of like databases and stuff like that, right? Like that you run your unit test against like an in-memory mock database that it's not actually a database, but it's something that will work for your tests.
Yes. So this is how, like, historically, the sort of the adoption of test containers has been progressing, is that you have your application and eventually you are like, I need to test this. I need to verify that it works. So you start looking for ways to run your applications, because you need some sort of environment to run it. It cannot be your production environment. It has to be similar to production. And then for some services you can have those in-memory solutions, right? It could be your database that is written in Java and running as a process. It could be your embedded Kafka to which your client can connect. And those inevitably fall short of the actual real system, because, well, they are mocking it. So they're like, you will have this situation where it's either not sufficient, the implementation of the mock is not sufficient, and it doesn't support some features, so you cannot test something, or like you cannot run some functionality that your application wants to have, or it will like just diverge and it will work with your mock embedded solution and won't work with the real thing. And honestly, I'm not even sure which one is worse, because they're both pretty horrible situations. So yeah. And the obvious solution to that is to run the actual real things that you're going to depend on in production. So if you work with a Redis cluster, right, you can run Redis in your development and CI for your testing purposes. If you work with the Postgres database, run Postgres locally for tests. And that's how test containers was born.
Yeah, and I think that it makes a lot of sense. It actually saves you a lot of time by actually testing against the real thing instead of like a mock, which is kind of great. And I've seen usually like teams that are not coming from the Java community, maybe Go, maybe Python, also like using, for example, you will see that whenever you create a project, you will create like a Docker Compose file right close to the project. So you can actually start the Docker Compose file with the Redis instance or whatever other service you need, and then just run your application to basically code locally, but also run maybe unit tests.
Yeah, and this is a common setup, right? Like sometimes like you need the infrastructure, and very often this infrastructure is encoded sort of once and given for you, right? It might be you 6 months ago when you started the project, when you created the Docker Compose file, or it could be your platform team or your developer experience team at the company that give you the infrastructure and say like, oh, this is how we run or how you're supposed to run things. And then the sort of the downside of that approach is that it's a very static configuration, right? Like you can run it once and it creates the environment for you, and you can use that environment, which often falls short when we talk about actually testing your application, because when you talk about tests, what you want to have is you want to have a flexible system where you can put your application in those like in the like edge cases. You want to test what happens when your data is this way, or you want to test what happens when your like your Kafka configuration is that way and your topics are running out of like partitions or something.
Space.
Might right. So like you want to put your application in those conditions, and then you verify the behavior in those. And very often those are sort of irreparable, right? So like it's if your data in the database is already sort of in a messed up way, it's very unlikely that the following tasks can work with that data normally, because specifically for the next test, maybe you need to mess up the data in a different way, or maybe you need to have like a series of actions that work. So like a single static instance is not enough. What you want to have the ability to create the environments for your application on the fly, preferably from the tests, which is what Testcontainers gives you the API to do exactly that. And on top of that, like you don't have to deal with YAML because the environment definition is in your programming language.
That's pretty good. And I think that you have like you have a very good point there about that, like creating different. So it's like it's not just a single environment. It's like multiple different environments configured in different ways for testing different things. And Testcontainers will actually manage the life cycle on when these things gets created and destroyed.
Yeah. So you get the API, you create the environment. We manage the cleanup. We sort of give you the integration with the frameworks and sort of the API for configuring things that you run in containers. For example, if you want to configure a database in a certain way, or your message broker, or you run a Kubernetes cluster and you like as a test container, right? And then you want to provide it with a certain configuration. We sort of give you the way to do that normally as a developer without even maybe knowing how to run particular technology in a container, right? And then you can do that as many times as possible. It's a trade-off between isolation and maybe the convenience for your tests. Yeah, but
perfect. I think that's good. So I think that we are ready to just get started on showing stuff, right? And for showing stuff, I think that I need to talk a little bit about Kubernetes. I will not explain what Kubernetes is. I will assume that you kind of know what it is. It's a container orchestrator. You can run applications on top of it. And it gives you that, like it gives you an API to deploy and run applications in the cloud. The main idea behind the Kubernetes APIs is that now you can actually create Kubernetes instances in multiple cloud providers, right? Like no matter which cloud provider you are running your applications, you can create a Kubernetes instance there and use the same APIs across all these cloud providers. And even on-prem, you can actually run Kubernetes on-prem, use the same APIs to deploy and run your workloads on top of that. If you are using Kubernetes, you will definitely need to create containers. So if we go back to the applications that we were showing before, interacting with Redis or Kafka, it doesn't matter which infrastructure do they need. You will have your app written in your language. You will add some kind of dependency in there. Then you will need to containerize that application, write some YAML files, send that to Kubernetes, and Kubernetes will run that application for you. Then, including in those configurations, you will need to have a way to connect to a Redis instance. And this is going back to what we were saying before, right? With test containers, you are removing all that infrastructure layer that is going to run your application in production, and you are creating a new instance of Redis for testing your application or for even developing your application. And I think that we will be showing that as well. But the idea is to remove all the things that you actually don't need for development purposes, but when you are deploying this application in Kubernetes, you will kind of need that. And I think that that's why I wanted to just cover kind of like quickly what Kubernetes is and how it will work for these applications that we are discussing, because I wanted to introduce Dapr having kind of like all this context in mind, right? So Dapr is a CNCF project. It stands for Distributed Application Runtime, and it actually comes to solve some of these problems that we have been talking about. Problems, challenges, or like common patterns that we will implement, no matter which kind of like application are we building, in kind of like using and exposing some standardized APIs. One thing is clear, like Dapr, it's not going to solve your relationship problems. If you have problems in your relationships, Dapr is not going to solve that, right? But besides that, it's coming to help you like building distributed application and solving some distributed application challenges. And as you will see, like in the Dapr website, you will see that we cover some of the things that Dapr kind of comes and help. Like you can see here in the list on the side, publish and subscribe, that's sending and consuming events, service invocation, making sure that applications can talk to each other. And the one that we have been mentioning quite a lot is like state management, which is storing state and reading state from a persistent storage. Dapr works outside Kubernetes, but if you are in the world of Kubernetes, Dapr works as like a Kubernetes extension. So it's something that you install on your Kubernetes clusters, and it will give you access to these kind of like local APIs for your applications to use. So I have created kind of like a demo application that we will be using for showing both test containers and Dapr in Kubernetes. That it basically has this very simple architecture, right? So you have a front end that is interacting with a bunch of backend services, like the read application that it's writing data to. Sorry, it's the wrong way of the arrows, but the read application is writing data to. Sorry, no, writing data. The read application is reading data from the database, in this case Redis. The write application is writing data to that database. And at the same time, the write application is sending messages to a message broker that the subscriber app can go and fetch. So it's just demonstrating kind of like very common behaviors, storing data, reading data, and consuming, messages that other applications are sending. And the front end is, working as the front end for all these services to work. So let me show you quickly that application. It's a very simple application. I will not show anything completely new here. It's a very simple application. You can write a message here, hello, webinar friends, right? And that's going to be stored in a persistent storage. We get a nice message there. And here, like in the right side, we are just reading all these messages. And here on the bottom, we are getting kind of like asynchronous notifications for all the messages that we send. Again, this is just to demonstrate different services talking to each other. Also, services writing to the storage, services reading from storage, and then asynchronous notifications here down on the bottom. The application, it's not super relevant, but the behaviors are, right? Like you are going to be doing these kind of things in your own applications. And if you can like work between some boundaries, you can actually start using Dapr for solving some very kind of like some of the problems that we mentioned before around infrastructure. So how does Dapr works? So if you install Dapr inside Kubernetes, what it's going to happen is that whenever you deploy an application and you tell that application that application is Dapr enabled, Dapr, with the components that are installed in the clusters, are going to automatically inject a sidecar right beside your application. So when you run your application on Kubernetes, now you are running your application and Dapr is attaching another container right beside your application. And that container is exposing a set of HTTP and gRPC local endpoints that your applications can use. These endpoints will give you access to Dapr components, right? And these components are the list that I showed before, right? Like you have the state store component, the PubSub component, and then you can define some resiliency policy for service-to-service invocations as well. There are tons of other components, but these are the ones that I'm demonstrating here in the application. And I think that this is kind of important because now, what you are doing is you are giving access to your application to store data without actually exposing to the application where that data is being stored. So your application can send an HTTP request to the local host where the application has access to the Dapr sidecar. And that request is going to be forwarded by Dapr to, for example, a Redis instance. By doing this, you are removing the dependency from inside your application to understand that it needs to connect to Redis, and also the URL and the password and the user for the application to connect to the infrastructure. You are delegating all that responsibility to Dapr, and Dapr is exposing a set of standardized HTTP or gRPC endpoints for your applications to use. In that way, no matter if you have your application in Java or in Go or in Python or in Ruby or whatever language you're using, you're always, as soon as you can send an HTTP or a gRPC request to localhost, you can access to all the Dapr APIs and all the Dapr services. By doing that, again, you are removing the dependencies from within your applications, making your applications smaller and less dependent on the infrastructure. So I just wanted to show a couple of things, Oleg, if that's okay with you, so we can just take a look at how does that look like for developers. But let me show you this kind of like in the cluster quite quickly. So what I have here is I have a Kubernetes cluster running in Google Cloud. And this is where I'm running my applications, the application that I just showed you, right? So I have the read application, the subscriber application, and the write application. You can see here that Dapr is, my application has one container, and then Dapr is injecting another container. That's why I have two containers running there. And the third one is actually Knative, another framework that it's running here on the cluster, that it's injecting another container there. But because this application has Dapr in it, again, if we take a look at the source code of this application, and that's something that Oleg will show, you will see that there is no dependency inside this application to Redis or anything like that. It's just using the Dapr APIs. And for all this to work, what you need to do when you install Dapr is installed inside the cluster, right? We can take a look at here. So we have Dapr installed there. So basically Dapr is monitoring our applications and saying, this application needs to have the Dapr sidecar injected. And as soon as the sidecar is injected, the application can start consuming those APIs. And you configure, the last thing that your platform teams will do is configure the Dapr components. But if you are using Kubernetes, you will know that that's basically a Kubernetes resource, in this case, components. As you can see, I have configured a state store component and a notification PubSub component in this case. And I can show you the configuration of these components so you can understand how this works. So describe component, state store. So what I've done here is I've created a simple configuration for a state store component. And in this case, the type of this component is implemented by Redis. So in this case, the Dapr sidecars that are deployed inside the cluster, they will say, okay, I need to connect to Redis, and I need to expose an API for the application to store and read data from Redis. And of course, because somebody needs to actually connect to Redis, here I have the credentials to be able to connect. So I have a Redis instance working in this URL, basically, and I'm consuming the password from a Kubernetes secret that was created in there. You can see that I'm running here the Redis instance. It's running there, so I'm basically connecting my applications indirectly using Dapr, using just an HTTP API to connect against that using those component configurations, right? Besides that, I'm not doing anything else. Dapr is in charge of connecting to Redis and just delegating all the requests that it's getting in the sidecars to that instance of Redis and storing and persisting data and providing data back when the applications are requesting it. When we see the code, we are going to analyze a little bit more how this works. But in general, if you have Dapr installed in your Kubernetes cluster, it's going to inject a sidecar for you to use, and your applications, your developers will be able to just use that API to perform different behaviors, like storing data or emitting messages and doing that kind of stuff, which they usually do. Does that make sense, Oleg?
Yes, and I like it how like, so my experience is mostly the Java applications, right? Mm-hmm. And then way back in the age when the Iron Man the movie was still new, yeah. Right? So 2000 yeah. Late 2000s, right? Mm-hmm. We in the Java ecosystem, everyone used application servers in some way, and they were the runtimes that were providing you with the components that you mm-hmm. can use to talk to the particular services, whether
That's right.
other services or whether like a data store or something like this, or implementing those like resiliency retries or fall-offs. And then obviously that like approach of having an application server doesn't scale and doesn't work in the Kubernetes environment, where, well, your applications are smaller. You cannot bring the like a massive application server to the normal Kubernetes environment and expect your people who are doing operations be happy with you. But I like how Dapr kind of sort of takes the best of that and gives you the single view into what those services are, centralizes the configuration for that, and sort of makes it like a native Kubernetes environment specific platform, which is very, very
good. And I think that the idea of using kind of like sidecars in this way is that you centralize the configuration, but you push it very close to the application, right? So developers are writing requests that are local to the same kind of like context of their container, instead of like just calling a remote service. And then Dapr is doing all the routing to make sure that you can reach to the Redis instance in this case. And then because it's exposing a simple API for developers, the platform teams can say tomorrow, well, we don't want to use Redis anymore. We want to use PostgreSQL, or we want to use any other state store for storing data, right? And that's where Dapr provides different implementations that you can actually swap, because you know that your applications are going to consume a stable API.
Yeah, exactly.
Yeah,
exactly. Right. So let's see. This is you showed how Dapr runs in a Kubernetes environment, sort of how the production side of this would work. But how would the like a local developer experience work for this? And this is where I can take over the screen. And this is the same slide. So we have the three applications, and they depend on certain Dapr components and configuration. And we locally don't have usually access to Kubernetes cluster, or as an application developer, I don't really want to know about the Kubernetes implementation details. I don't want to think in terms of pods. I don't want to think in terms of like applying YAML files to get the desired state, right? Like I'm a simple person. Like I want, as a developer, I want to concentrate on my business logic, and I want my environment just be there for me. So this is exactly what we're going to do with test containers. And so test containers is a way for you to run and test your cloud applications, cloud native applications locally. So as we talked about, test containers are a collection of open source libraries in different languages. So we have Java, we have Go, we have .NET, Node.js, Python, Rust, Haskell, and Ruby. Those are the most of the implementations were community contributed originally. They're under open source licenses that are typical for that language ecosystems. So it's all good. And what it gives you an API to run services in containers. So for our environment, right? For our environment, we would need to run Dapr services, and we would also need to provide the environment and those data store and message broker implementations. So test containers will manage the environment with those three services running. And this is what it gives you. Test containers libraries are libraries, so you include them as dependencies to your code. And the nature of a pun here is not lost on me. We call dependencies both the libraries and the services, but there are different types of dependencies. And it works for anything that your stack depends on, and available in a number of languages. On top of that, we're going to look into this, but there is a whole ecosystem of modules that define abstractions for you. So you don't need to actually know how to run particular services. but you can very easily just in 1 or 2 lines say that I would like a Postgres, or I would like a K3s cluster, or a Pulsar or local stack for AWS. So it's all very developer friendly, and there are a number of advantages why test containers actually shines. And some of them we talked about earlier is the flexibility of the lifecycle API. We can isolate the environments for the specific test cases versus or like very conveniently create them again and again and again, instead of relying on the static environment that we always need to sort of maintain and roll back to some certain state. And because it's all just code, like it's the library, right? So it's very, very easy to build abstractions. This is what we as developers do every day. And we can create complex abstractions that other people, including us in the future, can reuse. So one of those are the modules, but you don't necessarily have to stop at like encapsulating how to run a particular technology. You can do complex network topologies. So if you need to run a cluster of things, you can run a cluster of things. All the configuration is dynamic, so you can easily parallelize your tests. And in general, it gives you the sort of look and feel, the experience of writing unit tests, or just running your application without taking care of the environment. But it's a reliable integration test which run against the actual technologies, and this is how we do it. So let me show you my.
So Oleg, just to clarify there, I guess that just to clarify, compare with the example that I showed before, is that when you're running in Kubernetes, Dapr and the Dapr components that are running inside the Kubernetes clusters are doing a lot of magic, right? Like injecting containers right besides your applications and configuring a bunch of stuff that when you're running in your local environment, there is nothing that will do that for you unless you have something like test containers that can create these complex configurations of things and just run them besides your application.
Yes. So sort of what test containers does, you need to have an access to like a Docker environment to run the containers where we're going to run the services. But your configuration and sort of orchestration of the services that you want to run would be managed by test containers, which means that it will be defined in the code of your application, in the code of your tests, and it will just run sort of imperatively how you as the developer would expect it to run, right? So there is no complex orchestration. There are just like literal commands. Get me a Postgres database. Give me the address of that Postgres database so I can connect to it. Give me a Dapr container. My application, here's the Dapr container. Please connect to it and start working with that in a just imperative way of running the things. So let me show you the example. I have the same 3 applications that you showed us. Those are Java applications. So this is the read application, the simplest of them probably, right? So how you do that, you need to instrument it with your Dapr SDK. I don't know if you call it SDK, but you use the Dapr libraries for accessing things like, for example, the state store.
Exactly. Right. So if you look there, like at line 36, basically what you see, we are using the client just to go and request a state from a key value store in this case.
Yeah.
Right. So that's the only thing that the developer needs to know in order to basically consume data, like read data from a state store. And that's the Dapr SDK. That's Dapr client is coming from the Dapr SDK. That basically is just a wrapper on top of the gRPC and the HTTP requests. If you don't want to add that dependency, you can just do plain HTTP requests to localhost and the port where Dapr is running.
Right. But the benefit of this is that I, as an application developer, don't need to even know what state store we're working with, whether this is a Postgres, whether this is Redis. I can just use the Dapr client. I add the library to my application. So this is a Spring application. So I will have the Dapr SDK Spring Boot dependency in my application, and that's it. And my application is there. Now, I would like to run this application. And of course, to run this application, I need the environment. And for that, we're going to use test containers. So here's how we do it. We add the test containers dependencies. In this case, this is the Spring Boot test containers library. which we add. But of course, if you're not using the Spring application, you will add the test containers libraries, manually for the actual test containers libraries without the transitive relying on the wrappers from the application frameworks. And then in our test class pass, what we can do, we can create the environment that we would like for our application. So we would create a network, and on that network, we're going to put a number of containers. Generic container is the basic and most sort of the base building block of the test containers universe. It represents anything that runs in a Docker container. So in this case, we're going to run Redis, Alpine, and the whole configuration is in a very natural manner available to you in your IDE, right? Your IDE helps you to create those things. Even if you don't know what you can do, you can explore. Your IDE will suggest you what you can do, and you immediately can get the configuration for the container themselves. So in this case, we know that we need to run Redis, and it's a network application. We can expose the port 6379 within the container. We're going to put it on the network that we want, and we can do anything. We can override the commands. We can override the commands. We can override the environment variables. We can run anything, and we can configure anything that we can normally do on the container level with that. So we create Redis using the generic container. So literally just running that Docker image. We create the Dapr sidecar container that we instrument, and when we create the configuration saying that, okay, we are working with the read application. We expose the configuration. We copy the configuration files with the components that need to work for that. If you are interested, then this is the Redis configuration. So the Dapr sidecar knows that for state store, we are going to use Redis. So we create that one.
If you see, that's the same configuration file that I have running on my Kubernetes cluster, right? So we pick the same configuration file that it's running on my, let's say, production Kubernetes cluster. We just put it here, and it basically that's going to connect in the same way for these kind of like containers that are running locally.
Yes. So that is the configuration. We add the another Dapr container that will help us.
We're doing some other stuff.
Yes, other things, and we configure our application to know where the Dapr is running. So because those containers will be run in any Docker environment we provide, it can be local machine, it can be your remote Docker daemon. Our application here needs to know where the Dapr things are running. In the sort of classic use case where you use test containers to create environment with a database, you would use a similar mechanism to specify, oh, my database is running there, so please application connect to that database instead of any static configuration you have. So we dynamically start those containers, and then we're going to say that, oh, Spring application, this is where you connect to Dapr. That's it. So in our test class pass, we're going to create an application that will run our main class and use the configuration for the containers, from this common containers, and we can just run this. So I don't have any containers running. Look, Docker PS, right? No containers running, nothing. My environment is pure, and as an application developer, what I can do, I can just click play, and hopefully it will all work. So the test containers libraries will detect what Docker environment we are working with. In my case, I use Test Containers Cloud, which is a service by AtomicJar, where locally I have a small user space binary that proxies to a cloud where I get on-demand isolated powerful machines where I can run my containers. So my containers will run in a dedicated cloud VM, but my tests will think that, or my application will think that it runs locally. So here, my application starts and it runs, and I can see it working. I can see it working because in my application, I can go and say like, oh, give me the values, right? It will of course not give me anything. So the response is empty because there is no data yet. But it shows that it works. So actually my system went ahead, my test containers libraries provisioned me with the Dapr containers, with my Redis container, and it all works for me. And then I can use my application. In a similar way, I can run my write application, which is a very similar thing. The same thing, I inject my Dapr client into my application. I have my containers configuration, and this is word for word the same configuration that we have in the other place. So we can also extract that into a common library, if you will. But I can run my application here, and this is the write application, right? So I can run both applications locally. I can have my configuration be in a specific way, so my different projects will reuse the existing configuration in the existing containers. I don't have to do that, but in this case, because I want to show the local run, I can show that there are no the sidecars are created separately, but the placement container that creates the magic is shared. So now this is my write application. And in my write application, what I can do, I can generate my values, right? So if I go to my generated requests, where's my message? Here, I can post the message to test containers, or I can say Dapr. Let's do love. Can I do love?
Baby.
Okay,
yeah,
okay. I was a little bit worried that there's a
encoding issue. Yeah.
Incompatible URL syntax, but like we send the values to our data store, to our application, and it accepted them and then saved them in the state store using the Dapr client, right? So now if I go back to my read application and do the same thing, I will get the values here exactly that we created. So what is happening here is that I can run my applications locally, right? I don't have a Kubernetes cluster here. I don't have the YAML files that describe how I need to run or how I need to specify and wire those applications together. I have that information in a Java file that describes the configuration for the Dapr components, and I can run them. I can run locally also the, what's the third one? The subscriber app. It's a Spring application. It uses the same containers configuration, and I can run it as well. And it will connect as well to the same configuration of containers. And it even here, look, you can see that it received the messages that the write application was sending. Producing, so if I run one more here, let's see. Let's make this window shorter, and this window goes there. So let's see. Let's watch the log here, and then say, "Hello world," right? And you can see that the notification immediately receives the message. So all three applications here, all three services are working together. I'm running them, and they work locally. On top of that, it's not just the environment that was created with test containers for the local development, which is it's great, right? Because what the local development it enables me is just cloning those services, cloning those applications, and just running them. As an application developer, I don't need to care about the infrastructure. The infrastructure, this containers definition, they could be given to me as a jar file by my platform team. Right? And I can write my applications without even knowing whether we are using Redis or we are deploying to Kubernetes, whether that Kubernetes runs in a particular cloud or any particular Kubernetes implementation is in use. As an application developer, I can concentrate on writing my applications, and I concentrate on writing my tests. Because, for example, if I, let me stop the write application. The cool bit about this is that it's not just for local development. I can reuse the same configuration, the same containers definitions to write my application tests, and I can run them as I would normally run any JUnit test, and it will create the environment for me. Let's see. Let's try the other app.
Yeah.
I think
I think that it will fail because you have like the reuse true, right? So you have some containers and probably it's been attached to that, right?
Oh, yes. Yes.
Yeah,
Yes.
but that's
Let me.
but I think that the whole point there is that you can create these environment configurations for your tests and you can reuse them for both for developing the application and bootstrapping the infrastructure so it runs very close to your application. And then when you want to automate these tests to run in the CI system, you can use exactly the same configuration, right?
Yes. And as a developer, I need to see that green checkbox, right? So I'm going to stop the
Yes,
containers. The containers are stopped. And then let me just run this test again.
the test.
This is the test, right? So let me run the test again. We will create the containers and we're gonna set the messages to the particular ports, which is for the right app. We send the message foo and message bar, and then we expect the values to contain both of them. It doesn't. It's a sort of a little bit simpler test. It doesn't run multiple applications, but it's a very good example. It doesn't need the whole environment. It will not be able to return me the values if it would not be able to save them, and it reuses the containers that I'm running locally here. So the only thing, yeah,
go for it. Sorry.
Yeah, so the only thing that is necessary for me is an environment to run my containers, which any compatible Docker environment would work. It could be your Docker desktop, or it could be your any other Docker implementation. As a I would recommend you to try. If you want to try it, you can look at where's my slide? I can look at the Testcontainers cloud, which is the cloud service by AtomicJar. You can just go to that. You can start the free trial. What it gives you the 100% compatible in the same way of running your Docker environment in your development and into your CI platforms, because the actual containers are going to run in the cloud environment remotely, and the tests or your application development environment will only think that they're running locally. So there is no differences between particular Docker implementations or particular your operating system details or your architecture. It will all work the same way. And then, of course, you will get the centralized management, visibility, and observability things on top of that with the Testcontainers cloud. So
I need to say that service is pretty good. It's completely transparent, right? Like it's exactly the same as running your local Docker daemon, but in the cloud, and all proxied automatically. So yeah, super happy with it.
Except really better because you don't share your local resources with it. So
and you don't need to download containers, right? Like you don't need to download containers to your local laptop. It's all remotely.
Well, there are a number of benefits of that. Being the cloud, for example, it also scales much better. So if I want to run my test suite in parallel, I can enable sort of a several rails of my tests as processes, and then they will get if I want, I can give them isolated environments. So I don't need to run 4 times all the containers that I need for my test setup, but the full forks of the tests will run with the cloud. The cloud scales horizontally way better than any local environment. So there are a number of advantages to that. And if you are trying test containers, this is probably the simplest way to get started. So you can you are welcome to check it out.
Perfect.
So
I think
this
we
is how you enable the local development. So we are closer to being on time. So let's just try to wrap it up. So there are a number of takeaways, right? What did we see? We saw that using the right abstractions can enable the teams to go faster, right? If you don't need to spend time thinking about the particular integrations with the data stores or deployment practices, you can concentrate on business value of your applications. So Dapr allows you to detach yourself from those pesky problems of the infrastructure and just rely on the maybe this is your bit. So
on the APIs. No, I think that's pretty good, right? Like what we are trying to do here is we are trying to break the dependencies from the infrastructure and allowing making sure that developers are not forced to make these decisions of which data store they will use, and depending on what their application needs, right? You can actually delegate that to platform engineering teams that understand, the environment that it's available, right? Like the cloud services that they have to store information, and what's the best service to do that. And then enable developers to consume those services through these like Dapr APIs that are standardized to solve like common application challenges. And then, of course, this is all in the cloud. But when you're in the developer side of things, then the next one, test containers can help in that side.
Yeah. So on the development side of things, you can create the environments using test containers using your favorite language implementation, and have that environment to be reused for your local environment for running tests locally and for running tests in your CI environment, giving you the parity between those different setups and giving you the ability to reproduce failures very, very easily locally and fix them reliably. So once you fix them, you know that actually is probably going to work in production to very well. Right.
Perfect.
So, do I have more slides? Yes.
I don't think so.
Thank you.
Thank you, folks. Yeah. If you have any questions, you know where to find us, right? Like Twitter, you can drop us a message there. If not, get in touch in any other way. We are in Slack. We are all over the place. And I don't know, Oleg, any closing words? I'm pretty sure that we will be presenting this in a couple of conferences while we improve some of the integrations, right? There is a lot of work to do still on this. We can make it much better. But if you're interested in trying out currently all the examples that we showed today, there is a GitHub repository. We'll share that in Twitter as well. But if you have any questions, feel free to reach out.
Yeah, absolutely. Stay curious, stay healthy, learn things, develop applications, test and deploy those somewhere.
Awesome.
Right. Thank you very much.